We're going to continue going through chapter 9 and another way in which you can solve a quadratic. So we saw solving quadratics by graphing. We saw it by square roots. We know how to solve by factoring. And now we're going to look at another technique, which is solving by completing the square. So when you are completing the square for a trinomial, what you're doing is you're only going to be given, or sometimes you'll be given all three terms, or sometimes you'll be given two terms. And what we're asked to do is we're asked to complete the square, meaning we want to create a perfect square trinomial. So in order to create that perfect square trinomial, what we're going to have to do is we're going to have to take our b term, divide it by 2, and then square it. And that's what you're going to be adding in order to complete that square, okay, to create that perfect square trinomial. If you think back to what we saw when we did perfect square trinomials, that was the pattern that existed. So we have to take our b term, which in this case is 6. We have to take that 6, we have to divide it by 2, which will get us 3. And then we have to square that term, which will get us 9. Okay, so in order to complete that square, okay, what we're going to add to the end of this trinomial is a 9. And the reason that we're doing this, okay, and then we added that 9 is eventually what we're going to be able to do is we're going to be able to factor this. And this factors to a perfect square trinomial of x plus 3 times x plus 3, or more importantly, x plus 3 quantity squared, which is what we're going to be able to use in our technique of solving by square roots to eventually solve an equation. So same thing here on this one. We see that our b term here is -9. So we're going to take that -9, we're going to divide it by 2, and we're going to square it. Now, this is a fraction here, but that's okay. We're just going to square our numerator and our denominator. So we're going to end up getting 81 over 4. So 81 over 4 is what you would add to both sides, because I squared the numerator, -9 squared, and the denominator to get 81 over 4. So eventually, the reason that we're doing this is to actually solve the equation out. So when you're asked to solve an equation by completing a square, different from what we did in other types of equations when we wanted to set it equal to 0. We don't want to set it equal to 0 here. We want our constant term on the right side. Which we have here. The constant term is the term that does not have a variable with it. So in this case, it's that -15. Once we do that, we're going to find b over 2 squared. Okay? So in this case here, your b is -16. So when we do -16 divided by 2, and we square it, what we're going to get is -16 divided by 2 is -8. -8 squared is equal to +64. And what you do is you take that b over 2 squared, and you add that to both your left and your right side. So I add that 64 over to my left side. And then my right side was -15, and I have to add that 64 to my right side as well. So we're going to add b over 2 squared to both sides. Next, we're going to factor our left side. And it's going to factor to a perfect square trinomial. So x squared minus 16x plus 64 is going to factor to what two numbers multiply to +64 and add to -16. It's always going to be the same number twice. In this case, it's -8. So I'm going to write this as x minus 8 squared, because it's really x minus 8 times x minus 8 is equal to -15 plus 64 is going to be a +49. And now we have a problem like we saw in section 9.3. And we're going to solve by square roots. So from this point, I'm going to take the square root of both sides. The square root of x minus 8 squared is just x minus 8. And the square root of 49 is either positive or negative 7. So I'm going to have my two cases, or my two solutions that I'm going to have. X minus 8 is equal to positive 7, and x minus 8 is equal to negative 7. Solve for x here, add the 8 to both sides. You're going to get x is equal to 15 as one solution. Add the 8 to both sides here, and you're going to get x equal to 1 as your other solution. So again, what did we do? First step, get the constant term on the right-hand side. Then find that b over 2 squared and add it to both sides. Factor your left-hand side, as we've done right here, and then solve by square roots. The reason that we like completing the square as a method to solve quadratics is that it always works, okay? Factoring doesn't always work, okay? Not all equations are factorable, okay? Solving by square roots doesn't work when you have a middle term here. Solving by graphing can be difficult to do. So we like this solving by completing the square because I know it's always going to get me a solution. Now, let's take a look at this example. One thing that you need to make sure that you're doing when you're completing solving by completing the square is that your a term must be 1. So in this case, our a term here is a 2. That's no good. But what we can do is we can factor that 2 out, because I know 2 goes into everything here. So if I factor that 2 out, I'm going to get x squared, actually plus 10x actually before I do that, I'm going to get that constant term over there. Then I'm going to take a 2 out of everything. So 2x squared plus 20x equals positive 8. Now I'm going to take that 2 out of all of these guys. And I'm going to get x squared plus 10x equals 4. Now I'm going to find my b over 2 squared. So that's 10 over 2 squared, which is 25. I'm going to add that 25 to both sides. So 25 here and 25 here. So this is going to factor to x plus 5 squared is equal to 29. From here, take the square root of both sides. You're going to get x plus 5 is equal to, now 29 I don't know the square root of, so I'm just going to leave it like that, plus or minus the square root of 29. Subtract the 5, subtract the 5. X is equal to either positive square root of 29 minus 5, or x is equal to negative square root of 29 minus 5. And I can leave my answer like this, just in radical form. If it asks me to convert it to an approximate decimal, I can do that as well. Questions? Let's keep going. I will save the try these in class. Let's look at this one. Find the minimum value of y equals x squared plus 4x minus 1. Well, we know the minimum value we can get by taking negative b over 2a. That'll get us our x value, the minimum value. And then I could substitute that value in to get the y value. So my b term here is negative 4. My a term is 1. So x is equal to negative 4 over 2 times 1. X is equal to negative 2. Now, I want to find the y value there. So y equals negative 2 squared plus 4 times negative 2 minus 1. Y is equal to 4 minus 8 minus 1. Y is equal to negative 4 minus 1. Y is equal to negative 5. So just a refresher on how to find the minimum value there. Remember, the minimum value is the y value of your vertex. Same idea if we're asked to find the maximum value. Find your negative b over 2a. So x is equal to negative 2 times your a value here, which is really negative 1. So x is equal to negative 2 over negative 2, which is equal to positive 1. Now we have to find the y value. So y is equal to negative and then 1 squared plus 2 times 1 plus 7. So 1 squared is 1. Make it negative. You're going to get negative 1 plus 2 plus 7. Y is equal to, if we do this math out, 8. And 8 is my maximum value here. So just a recap and a reminder of how to find the minimum of the maximum values. Remember, it is the y value of your vertex. The y value of your vertex. Looking at example 6 here. Okay, it says which of the following functions could be represented by the graph? Explain. So a couple things here that we can notice from the graph. We can see right here that our graph is opening downward. It's got that mountain shape, so we know that a has to be equal to a negative. So because a is equal to a negative, I know that I can eliminate this one right in here. Now, if we're looking at these here, we know that our x-intercepts are both positive values. So I know that the last answer choice is a possibility. I know that both A and B are written in vertex form. And I know that my graph has shifted to the right. So my graph shifting to the right means that this is not a possibility because this means it would go to the left 4 units from my parent function. So I know that this one is out. From this point, I can't really determine based on this graph if it's B or D or could be both of them. So which of the following could be represented? This is telling me it's shifted right 5 units, is opening down and up 9, which could be the graph to the left. So this is a possibility. This is showing me it's opening down and I have x-intercepts at positive 2 and positive 8, which could be these values here. So this is a possibility. So you want to be able to make that representation or that connection between the algebraic representation and the graph based on the information that's given to you. We're going to save example 7 for class, as well as example 8. See you in class.